If 12 assemblers can complete a certain job in 4 hours, how long will the same job take if the number of assemblers is cut back to 8? I'm going to start by making a table here to organize everything. All right, so we've got, I guess I'll call it scenario 1, scenario 2. In the first one, we've got 12 assemblers, take 4 hours. And then it's wondering what would happen if we had 8 assemblers. So we're asking ourselves, is this a direct proportion or an inverse proportion? And the way to figure that out is we have to think logically about what we expect to happen. So if we have 12 assemblers and we lose 4 of them, so we have fewer workers, do we expect the time, I'll put a minus, we've lost workers, do we expect the time it takes them to do the same job to be greater or less? And I would expect the time to be greater. So if 12 assemblers can do it in 4 hours, I'd expect 8 of them to take a longer time since there's fewer of them working. So as one is decreasing, the other is increasing, and that means inverse. Now, to set up an inverse proportion, first I'll just begin setting up a proportion to equal ratios. The important thing to remember with inverse is the units in each ratio need to match. So if I put 12 assemblers here, I need to keep the other assemblers with it in the denominator. So 12 assemblers is to 8 assemblers. Now, if this were direct, I would put the 4 hours with the 12 assemblers since those go together. However, since it's inverse, you simply flip it. And that's what creates the inverse scenario here. And then let's just say X hours. Now I'm ready to solve. I'll go ahead and solve using cross multiply. So I have 8x equals 12 times 4, 48. All right, I want to isolate x now, so I'll divide 8, the inverse operation of 8 times x. What I do to one side, I must do to the other. X equals 48 divided by 8, 6 hours. All right, so I can come back up here, and my answer is 6 hours. Is that reasonable? As I lost assemblers, the time it took them to do the same job was longer, which does make sense.